Welcome to episode 2 of the Voron Trident Purple Plastic Eater Printer build. In episode 1, I had mentioned to you guys that in every single episode, I'm going to be introducing a new part or feature for the Voron that's going to differentiate this build from the other builds that you've seen on YouTube. Now in episode 1, that was the redesign of the functional parts, so the 3D printed parts, to be optimized for MultiJet Fusion printing. If you guys haven't heard of MultiJet Fusion printing before, check the description down below where you'll find links to the white paper for MultiJet Fusion printing. And if you guys are looking to purchase these parts for your printer, your Voron build, check out my website, embracemaking.com, where I've made these parts available to you guys printed in the MultiJet Fusion technology printing. And so in this episode, we're gonna be covering the installation of the print bed, the X gantry, as well as all of the Core XY belt routing. And so without wasting any more time, let's get started. The parts shown here in pink are the parts of the XY motion system that I've redesigned for MultiJet printing. And you can see that I've isolated them here for a closer look, and we're going to start by preparing these parts. As with the MultiJet parts that I presented to you in the previous video, part 1, I've also labeled these parts and embossed them with the right and left hand identification right on the parts themselves, so it's easier to determine which is which. One thing you'll also notice is that many of these pieces were previously 2 pieces when FDM printed and are now a single piece. We're going to start by installing the brass threaded inserts into these parts, and to do that we're going to use a heat set press. These brass threaded inserts are for M3 screws, and they are the short version of the inserts. If you've purchased these MultiJet parts from me, just keep in mind that when you are inserting these brass threaded inserts, that your soldering iron should not be on too high of a setting. Although this material can withstand higher temperatures than the typical FDM printed parts, you still do not want to have these inserts pressed in while the material is so hot that it turns into a soupy mess. When pressing the brass inserts in, you want there to be some amount of resistance, and the material should not be liquid, it should just be somewhere in between solid and liquid. When you're finished, your parts will look something like this, and you'll notice that the X carriage bracket received 4 of the brass threaded inserts. This small black piece here, which retains the proximity sensor at the back of the X carriage bracket, is not part of the kit that I offer. I printed mine in carbon fiber PETG, and it receives 2 of the brass threaded inserts. For reference, this is where it's installed in the X carriage bracket, and we'll get to that in a few minutes. The mount for the X-axis drag chain received 2 brass threaded inserts as well, and this part that I provide has the 2-hole pattern, which is meant for the IGUS cable chains. I do not offer the 3-hole pattern ones. Next, we can prepare these 2 parts here, which carry the X gantry on the 2 Y-axis linear rail carriages. For this assembly, you're going to need the right-hand side piece. We'll start with this one here. You're also going to need your 2 flanged smooth bearings. You're going to need the 20-tooth GT2 idler pulley. You're also going to need 2 M5x40 socket head cap screws, as well as 2 of the M5 nuts. Start by snapping in that 20-tooth pulley into the topmost position, and you'll notice that unlike the original Voron assembly, you will not need to add any sorts of spacers or shims. They're built right into the part. Then you can drop in the M5x40 socket head cap screw, and if you take a look at the bottom of the part, there's a receptacle for the hex nut. Go ahead and tighten that screw down. Just be sure not to tighten it too much where you risk cracking the plastic, and you do not want to risk binding that idler pulley. You can simply test whether or not it's too tight or too loose by spinning the pulley, and it should be able to spin freely. And if you try and move the pulley up and down, there should be no vertical play. After that, you'll take the 2 smooth flanged bearings and you're going to sandwich them together, and we're placing them in this lower position. Similar to the toothed idler that we just installed, you will not need to add any shims or washers to this bearing stack. The 2 bearings should snap into place with a light to medium amount of force, and it might help to get 1 bearing in place first and then slip the 2nd bearing in like I'm doing here. Once they're in place, they should be retained and they should not fall out. And of course, we are going to put another M5x40 socket head cap screw right down the middle to secure them in place. Another M5 nylon locking nut will get inserted into the bottom of this part, and then similar to the tooth bearing, you're going to tighten this down and find that sweet spot where it's not too tight and not too loose. When you're finished, it will look something like this, and we can move on to the left-hand side. The left-hand side is the identical process, and so we'll go through it here a lot quicker. The only difference here is that on the left-hand side, the toothed pulley goes on the bottommost position, and the smooth bearings that get sandwiched together go in the uppermost position. The same M5x40 socket head cap screws and the same M5 nylon locking nuts are used in this assembly as we're done on the right-hand side. Next, we're going to be installing the proximity sensor into the X carriage bracket, and you can see the slot that it goes into on the front of the bracket. On the back, we are going to be putting the retaining piece for the two brass threaded inserts on the back side. As you can see, I'm using the Omron version of the sensor. There are a few different options for the Voron kit, and this sensor will get secured into place using two M3x30 socket head cap screws. They will thread directly into the retaining piece on the back, and there are slotted holes which allow for vertical adjustment of the sensor within the X carriage bracket. The PDF manual states that the bottom of the sensor should be 6 millimeters from the bottom of the X carriage bracket, and that will be a good starting point for the sensor. And so you can go ahead and use a pair of digital calipers to measure that and ensure the sensor is in the right place before you completely tighten down those M3x30 socket head cap screws. In part 1 of this series, we label each of the extrusions, and in this step here, we're going to be using our E extrusion, and this is what's going to make our X gantry. We're going to need 6 of the M5 roll-in T-nuts. 4 of them will go on the top of the extrusion, and you can see the holes are biased to the outside. Another 2 of the M5 T-nuts will go on the bottom of this extrusion, but on the front face, we're going to be adding 8 of these M3 roll-in T-nuts. The quantity of the M3 roll-in T-nuts may vary depending on the size of the machine that you're building. In this case, I'm building a 300 by 300 by 300 Voron Trident, and so the length of my linear rail on the X gantry is going to determine how many of these roll-in T-nuts that I need. I'm going to be placing 1 roll-in T-nut for every second hole on the linear rail. The 4 roll-in T-nuts on the left-hand side have the holes biased to the left, and the 4 on the right-hand side have the holes biased on the right. Now we can take our linear rail and we can place it on top of all of the M3 T-nuts. We can use a small tool to align all of the holes in the T-nuts with every second hole in the linear rail. Then I'm going to grab 8 of these M3x8 socket head cap screws. I'm going to be applying a little bit of thread locker to them, and I'm going to be placing them inside of the holes in the linear rail, and of course tightening them down into the T-nuts. At this point, I'm going to make sure that they're not fully tightened down. We are going to be putting other parts on the ends of this extrusion, and we have to make sure the linear rail fits in between them, so you should still be able to slide the rail side to side if you need to. Now we can grab the 2 MultiJet printed parts that we prepared earlier with the pulleys, and those are going to be oriented onto the gantry like so. And so the 20-tooth pulleys are going to be facing the same side of the extrusion as the linear rail. On the top, we're going to be using these M5x10 button head cap screws to secure these pieces to the linear rail into those M5 roll-in T-nuts. On the bottom of the extrusion, we're going to be using M5x30 button head cap screws to secure the bottom of these pieces to those M5 roll-in T-nuts on the bottom of the extrusion. Be sure to use some thread locker for these button head cap screws, and then we can go back to the linear rail and we can use the 3D printed centering tools to center the linear rail onto the 2020 extrusion, and we can tighten those M3x8 socket head cap screws down. When applying the final torque to these socket head cap screws, I'm going to be working my way from the center outwards. When complete, the carriage motion should be very smooth. I've taken the printer and placed the frame upside down, and we're looking at it from the front side right now. We're going to take the assembly that we just made, and we're going to now be installing it on the Y-axis linear rail carriages. We need 6 M3x16 button head cap screws. On the right hand side, we're going to be installing 4 of them, and on the left hand side, we're only going to be installing 2 of them, and the 2 that we are installing on the left hand side will be closest to the front of the machine. As with most of the other screws in this build, you're going to want to apply some thread locker to these M3 screws, but do not fully tighten them down just yet. If you're finding that some of the M3 screws are not lined up perfect with the holes in the carriages, then you can shift some of those MultiJet printed parts around a little bit. Keep in mind that those pieces are secured to the aluminum extrusion with the M5 button head cap screws and the roll-in T-nuts, and so if you have to shift those 3D printed parts around a little bit, then you can loosen off the button head cap screws on the top and the bottom of the extrusion, and you can start to shift the plastic parts so that the M3 screws now line up with the carriage. Once you get all of the holes lined up, now we can start to square up the gantry with the rest of the frame. Using a caliper or some other measuring device, or even just a simple go, no-go gauge, you can slip something between the X gantry and that rear cross member of the frame to make sure that these two parts are perfectly parallel with one another. Once they are in line with one another, you can begin to tighten down the rest of those screws, and you can see that I did in fact loosen off the button head cap screws that are securing the MultiJet parts to the X gantry extrusion. I'm going to go back and forth quite a few times and gradually tighten down all these screws, making sure that as I do this, I'm not shifting any of the components to misalign that X gantry and that rear cross member. Once all of the screws are tight, I'm going to double check my work with the caliper and slide it back and forth a few times. Also make sure that the gantry slides freely and does not bind. After that's complete, I'm going to triple check my work, and I'm going to bring my square into the picture here, and I'm going to check the squareness of the gantry to the side extrusions that the Y-axis linear rails are mounted to. If you've carefully constructed your frame up until this point, that gantry should be nice and square with the rest of the frame. The printer frame is now upright again, and we're looking at it from the front. We're going to be installing this bracket here for the X-axis drag chain. Remove the 2 M5x10 button head cap screws that go on the top of this MultiJet printed part, and we are going to be replacing them with M5x16 button head cap screws. Place the bracket on top, orient it in this position here, and tighten down those M5x16 button head cap screws. Now we're going to address the Core XY belt routing, and to do that we need to bring in this part that we prepared earlier, which is the X carriage mount for the print head. On the back of this part, you should see tooth-like features that will engage with the teeth on the belt. We're going to do a dry run installation of this belt because right now my belt has not yet been cut, and it's probably about 10 feet long, and so it's going to be very awkward to work with at first. I'm going to slip it in through the back of this part, and then we're going to use some M3x8 socket head cap screws to secure this part to the X carriage. With the original Voron parts that were FDM printed, this bracket used to be 2 pieces. Now with the MultiJet printed parts, it's a single piece. This is going to make the belt installation ever so slightly more challenging, but overall it's not too bad, and I do have a method for it, so definitely follow along here in the video. Once you get the M3x8 screws tightened down just enough that that belt will not slip, we can now start routing the belt through the rest of the pulleys and idlers. Right now we're working on the A drive belt first, and so it's going to head over to the right hand side of the machine, and you're going to want to thread it through and around that 20-tooth pulley on the top side of that 3D printed part. Because the belt has not yet been cut and it's still very long, it's going to be very awkward to work with, and you're going to want to make sure that the belt is not twisted before you start threading it through and around the pulleys. If you do find that it is twisted, you're likely going to have to remove it and start all over again, because there's not enough room between the pulleys and some of the other parts to get it untwisted. And you'll see that I run into this problem here, and then I will start over again and rectify the issue. Once you get the belt around this first toothed pulley, it's going to come up towards the front of the machine, and then you're going to have to feed it around the front right hand side tensioner. Getting it through the tensioner is a little bit tricky, but it can be done using some sort of thin tool. In my case, I'm going to use just a simple razor blade, and I can actually slip the razor blade between the 3D printed part and the frame and push the belt so that it starts turning itself back around, and I can get it through the other side and back towards the back of the printer. The belt will then get routed along the inside of that right hand side extrusion and will pass between the narrow gap between the MultiJet printed part that carries the X gantry and that aluminum extrusion. It's going to be quite a tight fit with minimal clearance, but there should be nothing rubbing against one another. Now we're looking at the printer from the back side, and you can see here that I'm going to wrap this belt around that top left hand side smooth pulley. It's going to go through the A drive block, and then we're going to be wrapping it again around the tooth pulley from the stepper motor. There is still a lot of belt here to work with because again, we have not yet cut it, so it's going to be very awkward to do. But once you get it through and you make sure that that belt again is not twisted, then you're going to feed that belt again through the A drive here around the smooth pulley at the top, and it's going to cross the entire back side of the machine towards the right hand side of the printer right now. Once you pull the belt across the printer, it's going to make a 90-degree turn around the other top pulley here that is smooth, and it's going to fit right between that pulley and the frame. This is another tight fit, but again, it should not rub against any of the stationary parts. Looking at the printer from the front, we're going to route that belt along the inside of that side extrusion member and then through the MultiJet printed part. This one's a little tough to get it through there, but that belt's going to take a 90-degree turn back towards the X carriage. You might notice here that I have those 3D printed tools that center the linear rail on the X-axis gantry installed, and I'm using those to prevent the X carriage from sliding back and forth while I keep pulling on the belt. Now I'm going to loosen off those M3x8 socket head cap screws holding this 3D printed part to the linear rail carriage, and this is going to allow me to slip the other end of the belt through and around this part so that we can establish the length of the belt. Before you cut the belt, make sure that your tensioners are completely loosened off on both sides, and this is going to make sure that when you do cut the belts that you have the maximum length that you'll need for the loosest tension, and that's going to give you the most amount of adjustability when you go to finally tension the belts at the very end. Now I'm going to trim the belt, and on the right hand side you can see that I'm holding the side of the belt that we originally fed through that bracket. I'm holding it with one finger, and I've pulled through a generous amount of extra belt, probably about an inch and a quarter, and I'm going around making sure that the belt is properly engaged with all of the pulleys and it has not slipped off of its track anywhere. I would suggest holding the carriage like I'm doing here, especially if you're using the MultiJet printed parts that are a single piece, and then pulling the loose end of the belt so that you get a certain amount of tension by hand. Then you can trim the belt, leaving a little bit of extra on there, and we're going to remove it to cut an equal length for the B drive. Note that I removed the proximity sensor to gain more room to work with. And so once you've cut an equal length of belt for the B drive, you're going to go through that entire process again on the A drive belt and install it with the same path that you just previously used. There is a lot less belt to work with now, so it should be much easier and much quicker to do. Obviously, make sure that the belt is not twisted again, and once you have it in place, you should be able to pull it through the back of the carriage using some small tools like needle nose pliers to get that last little bit of belt through that window. The M3x8 socket head cap screws securing this bracket to the X carriage will have to be loose so that you can get these belts routed through. And now we can take the B drive belt and we're going to route it the same way that we did with the A drive belt, except we're going to start on the left hand side and it's going to head in the opposite direction. The belt will thread in behind the 20-tooth pulley on the bottom of this MultiJet printed part, and then it will head back towards the front of the machine towards the left hand side belt tensioner. And in the same fashion as we did on the right hand side of the machine, the belt will loop itself around the left hand side tensioner. Make sure that the left hand side tensioner is completely loose, and you can use a thin tool like I'm using here, which in my case is a razor blade, to just push the belt and manipulate it so that it fits around the pulley and loops back around towards the back of the machine. Once you get it to go around the front tensioner, it's going to slip between the X gantry and that side extrusion and head towards the back of the machine. Looking at the printer from the back, on the right hand side of the printer, you can see the smooth bearings on the bottom of the B drive bracket, and that belt will get pushed through there, and then it's going to take a turn around that smooth pulley and it's going to head back towards the front of the machine and wrap itself around the tooth pulley on the B drive motor. Once it's around the B drive motor pulley, you can use a tool to route it back towards the rear of the printer, then around the smooth pulleys at the bottom of that bracket and across the machine to the left hand side. The belt will then take a 90-degree turn towards the front of the machine around that smooth pulley on the bottom. Looking at the printer from the front, the belt will take its final 90-degree turn around that smooth pulley and head towards the carriage. I'm using a hobby knife here to help pull the belt through that carriage piece, but you could also use a flathead screwdriver or other small tool, even some needle nose pliers to pull that belt through and then get them in place where we can finally tighten down this X carriage bracket. Before you tighten down that bracket, double check that the belt has not fallen off any of the pulleys and that all of the teeth are engaged. Then you can take the loose ends of the belts and you can use your fingers to pull them towards the front of the machine as hard as you can to induce some amount of tension in there. Using some pliers, you can pull all of the belts together at once so that you're not pulling one end and the other end of the belt is coming out. And then even by hand, you can grab all of the belts by hand all at once and give them a nice wiggle back and forth so that those teeth in the back of the X carriage bracket are not going to prevent you from pulling more tension into that system. And then once you get an appropriate amount of tension by hand, you can go ahead and take your hex key and start to tighten down those M3x8 socket head cap screws. This is going to lock the belts into position. Because the belts are equal length, you want to make sure that the free ends of the belt are sticking out the exact same amount so that there's an equal amount of tension in each of the A and B drive belts. And now that all 4 of those M3x8 socket head cap screws are tight, we're going to remove one at a time and apply the Loctite to each of these fasteners. While we remove one of the screws, the other 3 will be able to maintain their grip on the belts so that they do not slip. The reason we're doing it this way is that otherwise, if we had to try to apply the thread locker while we were holding the tension on the belts, we just don't have enough hands to do that unless you have a partner helping you with this task. Now you can see that I've reinstalled the inductive sensor and that wire will run between the 2 belts. I'm going to check that distance from the bottom of the sensor to the carriage and it should be about 6 millimeters. I'm going to make sure those bolts are tight and then we can do the final trim on the belts. The belts should not stick out past the 3D printed bracket, otherwise the pieces for the hot end and extruder will eventually not fit on and the belts will interfere. Now we're going to switch gears here a little bit and I have one of these beautiful ultra flat beds from Mandela Roseworks and I'm going to be cleaning it with some high percentage IPA wipes. You will likely have to clean this surface multiple times, and after each pass you'd be surprised how much dirt and grime and oils still keep coming off of that surface. You can easily identify the top side of the print bed by the counterboard holes. Once you're done cleaning the surface, you can now prepare your magnetic sheet, and you can flip it over and peel back about 2 inches of the backing paper. There are a lot of drawn out videos on YouTube of how to install a magnetic build plate onto your 3D printer, but this is pretty much going to capture the essence of it. You want to start by lining up the edge of the magnetic sheet that has the adhesive now exposed with one of the edges of your print bed, and then you want to work your way from the center to the outer edges using a paper towel or some other soft object, and this is going to ensure that no bubbles or air gets trapped between the magnetic sheet and the build plate. As you work your way down the magnetic sheet, you'll be slowly peeling back the protective backing, exposing more of the adhesive layer, and then continuing to work from the inside out. Take your time with this and pay attention to the formation of any bubbles or trapped air, because it's easier to peel back just a little bit of the magnetic sheet if you notice any right away versus having to peel back the whole thing if you notice some bubbles at the very end. And if you've not yet purchased your magnetic flex plate for your Voron or any other printer you're looking for, be sure to check out my website, embracemaking.com. The spring steel build plates that I offer are double-sided, and that means one side is textured, one side is smooth with my logo on it, and both sides are PEI coated. Of course, the magnetic sheet is included, and I can have these made for you in any size you want, so it doesn't matter which size Voron you're building, or if it's another specific application that you're having a hard time finding a build plate for, I can get it for you. With the magnetic sheet attached, we now have to cut out some of the holes to gain access to those counterbores on the top side, and so I've flipped the build plate over and I've elevated it on these pieces of wood. I'm going to be using the pre-drilled holes in the aluminum build plate to locate the holes where I have to cut out some of the magnetic sheet to gain access to the counterbore holes. Now, unfortunately, in this clip, I make a mistake and I'm drilling out the wrong holes. These 2 holes here along the front edge are for a Voron V2 series. I am, of course, building a Voron Trident, and so I've drilled out the wrong holes in the front. For the Voron Trident, I should have drilled the 2 holes on the side. The hole I'm currently drilling at the back center is correct for the Voron Trident. I'll fix those other 2 holes off camera, but once we flip the build plate back over, you can see how the holes help me locate the counterboard areas that I'm now going to cut out with a hobby knife. I would suggest using a fresh blade on your knife to do this, and you can work your way around the hole rather quickly. A very sharp blade will make quick work of the magnetic material, and you can use the aluminum plate itself as a cutting guide, and the blade will follow the counterboard hole. You should be able to achieve a very nice smooth cut, and the magnetic sheet should not be disturbed at all or be lifted off of the aluminum plate. And you're going to repeat this process for the other 2 holes. Now we can prepare the bottom surface for the heating pad. Again, we're going to clean this surface with more IPA wipes and make sure that there is no residue left on the surface. In the exact same fashion that we adhered the magnetic sheet to the build plate, we are now going to be sticking the heating pad to the build plate. Make sure you identify which is the front edge and which is the rear edge, because you want the wires of the heating pad to stick out to the rear side of the build plate. And the rear side of the build plate can be identified as the edge that has the hole drilled in the center. Center the heating pad on your print bed, and using the same method as the magnetic sheet, slowly peel away the backing paper while pressing down on the middle and working your way to the outer edges of the heating pad to make sure no bubbles are trapped underneath. When you're finished, it should look something like this. Now we can install the thermal fuse, and in the PDF instruction manual it calls for an M3 screw, but there is no place on this build plate for an M3 screw. So I'm going to be using this M5x10 button head cap screw instead, and I'm going to be applying a little bit of thread locker on it. There are threaded holes to the left and right of the center hole at the rear of the bed, and that's where the thermal fuse is going to go. As you can see, the wires of the thermal fuse are pointing to the outside of the bed, not towards the center, because if you point them towards the center, likely the mount for the print bed that goes in the center will get in the way. Next, we're going to install the ground wire on the print bed, and don't be like me and install the thermal insulation first. I had to peel back some of the insulation and then scrape away some of the adhesive to get a proper electrical connection between the connector and the print bed. I'm going to be making a separate video dedicated to the wiring of the machine, but because this build plate is going to be installed in the next few steps, it's best that we make these connections now, because later on it's going to be too hard to do with the build plate mounted. If you've purchased a wiring kit from a vendor, this ground wire may or may not be included in that kit. It was not included in the kit that I purchased. The wiring kit that I purchased did not come with one of these ground wires for the print bed, but luckily I had some extra ground wire laying around, as well as one of these connectors. I'm using a spade terminal here, but it would be ideal to use a ring terminal instead. Use the shortest M5 button head cap screw you can find, along with some thread locker, to secure the terminal in place. Make sure the M5 screw is not protruding through the top side of the print bed and pushing the magnetic plate up. Now you can avoid making the same mistake that I did, and you can install the insulation on the bottom of the print bed after doing your ground wire. The insulation has a very sticky adhesive backing, so it will stick no problem to the entire bottom of your build plate. To get the build plate mounted, we are going to have to use extrusions G and F from our extrusion kit. As I had mentioned before in the first episode of this build series, the extrusions were labeled with letters to identify each one according to the PDF instruction manual. Extrusion F has a threaded hole in the end that we're going to be putting an M5x16 button head cap screw in, and extrusion H has a hole in the center for the blind joint. Make sure the extrusions are square with one another, and make sure that extrusion F is centered perfectly on extrusion H, and then complete your blind joint by tightening down that M5x16 button head cap screw. Now we're going to be inserting some of these M5 T-nuts, and so 2 of the M5 T-nuts will go into the end of this piece here, and the holes will be biased towards the front edge. Then we're going to follow it up with an M3 T-nut, and the M3 T-nut will also have the hole biased towards the front edge. Now we're going to do the same thing on the horizontal extrusion member with the 2 M5 roll-in T-nuts and a single M3 roll-in T-nut. In the PDF instruction manual, it depicts the M5 roll-in T-nuts in this orientation here, with one hole going towards the outside and one towards the inside, and then the M3 nut with the hole biased towards the outside. I found that that did not work for me, and I had to turn the middle M5 T-nut around so that both holes are now facing the outside. At this point, we can install a few more of the roll-in T-nuts, and on this side of the extrusion, there are going to be 2 of these M5 roll-in T-nuts, and the 2 holes are going to be facing away from one another. Then on the other side of the extrusion, there will be 2 M3 roll-in T-nuts, and those 2 holes will be facing the same side, which will be biased towards the horizontal extrusion member. When you're finished, it will look something like this. Now we can prepare and install the MultiJet printed print bed support pieces. Each of these pieces will have one of these spherical bearings press fit into the bottom of it. And for my build, I'm going to be using these spherical bearings from IGUS. 3 M3x6 button head cap screws will secure those bearings into place, and the PDF manual does not call for it, but as you can see here, I've added some small M3 washers to extend the bearing surface to make sure they really hold those bearings into place. And just another assembly trick here, if you're finding your bearings are not a tight press fit into the 3D printed parts, doesn't matter if you're using my parts or FDM printed parts or IGUS bearings or metal bearings, you can use a dab of hot glue around the outer face of the bearing to make sure that it is better retained within the bearing bore if it's a bit of a sloppy fit. For each of these print bed mounting brackets, we are going to be using M5x10 button head cap screws along with some thread locker to secure them into place, and those button head cap screws will thread into the M5 roll-in T-nuts. On the horizontal extrusion, the 2 brackets will have the bearings facing the front of the machine, and you can see that I've lined up the outside edge of the printed part with the outside edge of the extrusion, and the rear bracket will be oriented like this. Now we're going to get this assembly installed onto the printer frame, and we're looking at the frame from the front side right now. The horizontal extrusion member goes across the front of the machine, and those MultiJet printed brackets that we just installed will support this frame on the other MultiJet printed brackets that are attached to the Z linear rail carriages. M5x16 button head cap screws will go through the spherical bearings, and there'll be an M5 nut that goes through the bottom, and that's going to fasten this assembly down to the frame. If you're finding there are major misalignments between the holes in the spherical bearings and the receiving holes in the MultiJet printed parts that this whole assembly is being supported on, then you can loosen off the M5x10 button head cap screws that attach the print bed support parts we just installed onto the extrusion members, and that's going to allow you to shift those printed parts around to get the proper alignment. Go ahead and do this for all three of the spherical bearings. The print bed would normally be supported by these M4 thumb screw style nuts. M3x16 socket head cap screws would pass through the print bed and sit inside of the counterboard holes through the M4 thumb screw style nuts and into the M3 roll-in T-nuts. But the issue that I had was the added thickness of the print bed insulation on the bottom. The M4 thumb screw style nuts were just not tall enough to accommodate the thickness of the insulation, and so I had to print my own spacers. I printed these with carbon fiber PETG, but I'm hoping the print bed will not warp them over time, otherwise I will have to replace them with a higher temperature material such as nylon. Now I can take the M3x16 socket head cap screws, place them through the counterboard holes in the top of the print bed, through the spacers that I just told you about, and into the M3 roll-in T-nuts that are sitting on the top sides of those extrusions. I'm going to do this for all three corners of the print bed. Just take note here that the rear M3 T-nut will set the center of your print bed, and the two M3 T-nuts at the front will determine the skew of that print bed from left to right. So what I did here was I started with the rear one, and then I started working on the left and right. And the left and right ones, if I need to shift them around a little bit, I'm just going to make sure that they're not tightened down all of the way. And then I can move them left and right so that the print bed is also square with the frame and it's not skewed or rotated within the frame. An easy way to determine if your print bed is properly centered is to use a caliper between one of the brackets and the edges of the print bed and check both sides to make sure the distance is equal. The last step in this video is to install the Z end stop switch, and I purchased one that was pre-made, and it's known as the SexBolt end stop switch, and it works on both the Voron V2 and the Voron Trident. However, I ran into a few issues, and so I had to redesign the housing and add a little part. And what you'll see here is the inner components of this end stop switch. And so in my one hand here, I'm holding the Chicago bolt that goes through the bore in the center of this plastic part. There are some bushings not pictured here, but essentially it goes through that bore and presses down on the limit switch on the purple PCB that you see in the bottom of the screen right now. One of the problems that I had was that the 3D printed housing that came with my switch was too tall. And so when I bolted it on to the aluminum extrusion that carries the print bed, it was interfering with one of the MultiJet printed parts. The weird thing is that those MultiJet printed parts that I redesigned are the same overall outer dimensions, and so in theory, this part would also interfere with a regular FDM printed Voron part. What I did to resolve the issue was redesign this housing, and so on the left-hand side, you can see that the housing is shorter than the one that came with the kit on the right-hand side. The second issue that I had was that the Chicago bolt, which essentially makes the button for this end stop, was drooping too low. The added insulation of the print bed moved the print bed up higher, along with those 3D printed spacers that I showed you in the previous step, and this was preventing the button to stick up above the print bed. I printed a very small spacer that will fit into the end of the socket head cap screw that gets threaded into the bottom of the Chicago bolt, and that's going to space that Chicago bolt up a little bit higher so it should sit above the surface of the print bed. What I'll do now is reassemble all of these parts so you can see how they go back together. The Chicago bolt passes in through the top, through those bushings that I transplanted from the old part into the new 3D printed part. The socket head cap screw, I'm going to add a little bit of Loctite on the threads, and that's going to thread into the female thread of the Chicago bolt. It's hard to hold on to the other end with any tool, and you're mostly just going to hold on to it with your fingers, and so this bolt here will not go in very tight, but it should be tight enough that it will not back off on its own. Now we can take the small 3D printed spacer and insert it into the bottom of the socket head cap screw. There's a very small hexagonal feature on the end, and that should fit in where the hex key would normally go into the top of the socket head cap screw. It'll just be an interference fit, and if you can't get it to fit that tight, try a little dab of hot glue. You're going to need some needle nose pliers to get this piece to fit inside, as it's a bit of a snug fit. You can use the pliers themselves or another tool to press that plastic part into the socket head cap screw, and it should look like this. The plastic part should not obstruct the movement of the bolt, and it should all still press down very smooth. Place the PCB back on the bottom and test the function of the button. With the PCB in place, the button on the limit switch should not be pressed down. You should have to press the Chicago bolt down to hear the clicking noise, and you should be able to feel it through that bolt that the limit switch is being engaged and the switch is being closed. If you're finding that the limit switch is being closed without pressing down on the Chicago bolt, then you will have to take that plastic spacer out and you'll have to scale it in the Z direction to be thinner, and then reinstall it and try again. Reinstall the 4 screws that hold the PCB into place, and they will thread themselves into the plastic part. Check the video description down below if you're looking for the STL files for these parts. Now we're going to install these parts into the side of the aluminum extrusion that supports the print bed. In an earlier step, we installed these M3 roll-in T-nuts, and we're going to be using these to hold the limit switch in place. Take the new limit switch assembly along with these M3x20 socket head cap screws that are installed through the holes that run horizontal, and they are going to be tightened down, and that is going to secure the limit switch onto that piece of extrusion. I've slid the limit switch over to be as close to the print bed as possible without running the risk of that Chicago bolt interfering with the removal of the magnetic build plate. When you're finished, it should look something like this, and you can see where I'm pointing right now to the corner where that component would have interfered with the bracket holding the print bed up. This is why I had to redesign this part. That concludes episode 2 of the Voron Trident Purple Plastic Eater printer build. Now, if you guys are looking for those MultiJet printed parts for your machine, check out my website, embracemaking.com. I've got those parts as well as build plates and a few other things for the Voron Trident coming, so keep up to date with what I have to offer. Your support goes a long way with helping me make these videos. I spend a lot of time editing and filming them, hoping to bring you guys some value in the content that I'm providing. And if you guys are enjoying this video series, be sure to subscribe to my channel. I also really appreciate your support in that sense, or any other way that you wish to engage with my content. If you have questions, put them in the comment section down below. I try to get back to everybody. Thanks for watching, and I'll hope to see you guys in the next episode.